Hello everybody. In my previous lecture, I had put forward to the interested student the concept of the special theory of relativity. I would now like to derive the time dilation equation and see the consequences of that. So this is the time dilation equation, derivation. So we have a spacecraft here shown, and there is an observer O inside that. And let us assume that this height shown here is L. So one ray of light comes from here and it goes down. This is the detector D, and the source is here. So as the light falls down, the time taken for it is length upon c. This is of course derived from c is equal to L upon t. Now this is provided the spacecraft is stationary. Assume now that this is being observed by another observer here. You can see the eye here. Observers here. And he is observing that this spacecraft is actually moving with a velocity v in this direction. So velocity v in this direction, and the source of the ray starts from here, and instead of falling directly down, since the spacecraft is moving in this direction, the detector has actually reached here. So the ray of light moves in this direction now. For this observer shown here, let's call this observer O dash. The time taken will be T dash. But for the observer inside the vehicle, inside the spacecraft, it would just be T, and he would just see the ray coming straight downwards. Whereas this observer O dash will see the ray coming in a slanted form like this. C. So the distance traveled is C into T dash. Meanwhile, this is V into T dash. Now we are going to use the Pythagoras theorem here. This is the triangle here. V into T dash. This is C into T, and this is C into T dash. Now when we apply the Pythagoras theorem, this is what is going to happen. C square T square. So this is equation 1, the Pythagoras theorem. We move this V square to this side, and we have a mathematical equation like this. T1 square. Now to remind you, T dash is the time for the observer on Earth. And T is the time for the observer inside the spacecraft. Inside the spacecraft. Let us see how these two are related. So with a little bit of rearrangement, this c square, you divide numerator and denominator with c square, and we have this equation finally, that is T dash is equal to T upon root of 1 minus V square by C square. Now let us take a case in which V is 0.9 times C. That means we are traveling almost at 90% the speed of light. So if I substitute C as V as 0.9 C here in this equation, this gets squared, and after doing cancelling the C square, a little bit of calculation, you get T dash. T dash is equal to 2.294 times T. So this is just one of those cases Now, this only means that t dash is 2.294 into t. Let's consider two brothers, say for example Astro and Lazo. Astro is an astronaut and Lazo is his lazy boy on Earth. Let's assume that case. Now this Astro takes a spacecraft and moves away and perhaps takes say 40 years of Earth time. That is, his brother Lasso is on Earth, whereas Astro goes for 40 years and comes back. So when we use the equation, 40 is equal to t dash into 2.294. Sorry, there's no dash here. Sorry. Rearranging, we get t is equal to 17.43 years. So this means that the astronaut, Astro, has aged only 17.43 years, while as Lazo has aged 40 years. Now, is there any proof of time dilation? Yes, there is a proof. In fact, extremely accurate clocks have been flown on jet aircrafts, and the difference in their time readings have been found. There is a difference. Moreover, in nature, subatomic particles called muons are created by cosmic ray interaction. Usually they disintegrate in 2 into 10 to the power of minus 6 seconds. So since they disintegrate, their half-life is less, they should not have time to reach Earth. But because they travel close to the speed of light and time dilation occurs, this actually extends their lifespan. So you can see that time dilation does occur, and this would only mean that there is different times in different observers, and clocks on a space shuttle are seen slightly slower than the reference clocks on Earth. Thank you for watching. I hope you understood what I wish to say. Good luck, everybody. Have fun and enjoy learning. Thank you.